So we so we will be discussing discrete time Fourier transform now. We know that discrete time Fourier transform, discrete time non-periodic periodic Fourier transform. We know that Fourier transform, it is used for non-periodic signals. Okay, non-periodic signals. So in this section, we will be discussing Fourier transform of discrete time signals. They are of course non-periodic. That is why we say discrete time non-periodic Fourier transform. Discrete time non-periodic Fourier transform. Discrete time Fourier transform is generally used to represent a discrete time non-periodic signal. Okay, it is used to represent a discrete time non-periodic signal as a superposition of complex sinusoids. Superposition of complex sinusoids like discrete Fourier series. जिस तरीके से discrete Fourier series में हम करते थे that it is summation और superposition of complex sinusoids, इसी तरीके से यहाँ पे भी यही चीज होती है. discrete time Fourier transform is nothing but it is actually used to represent a signal which is non-periodic. वहाँ पे जो signal हुआ करती थी वो periodic हुआ करती थी. तो what we are basically trying to assess in this frequency domain analysis, because this is a frequency domain analysis topic, we are trying to basically analyze each signal, whether it is non-periodic or periodic, in the form of complex sinusoids, in the form of its fundamental parts, in the form of its harmonics. So that is the basic idea behind this all discussion. So like we used to discuss there, it is also used to represent a discrete time non-periodic signal as a superposition of complex sinusoids. Moreover, the discrete time Fourier transform, it would involve a continuous sum of frequencies. Okay, because as I said that the whole idea is to break down a signal into its frequency components, into its complex sinusoids. That is the whole idea. Now you have to assess, or you have to find the impact of each frequency component, each complex sinusoid on the entire signal, whether it is periodic or non-periodic. So it generally involves a continuous sum of frequencies, those individual frequencies, okay, over a period of over one period. I can say one period, over one period, that is on the interval of minus pi, any frequency omega equal to it is greater than minus pi or less or equal to plus pi, that is minus pi to plus pi, because 0 to 2 pi is one period, minus pi to pi is also one period. तो जो frequency components add होती है, that is in one period, because one period, if the signal is periodic or non-periodic, it can give you the complete picture, of the entire signal. ठीक है? What is sigma here? What is omega here? Where
Unit of
omega
radius.
here, omega has units of radians, So it means it is radians. It is actually frequency in radians. That is 0, pi, 2 pi, whatever it is. So we can say then, thus discrete time Fourier transform, it or discrete time Fourier transform representation of time domain time domain signal. Okay, discrete time Fourier transform representation of a time domain signal involves an integral over frequency over frequency as given below. ठीक है, जैसे नीचे मैं लिखूंगा इसको. So what is integral? Integral means summation. So it involves an integral over frequencies. You have to sum up the effect of various frequencies. So we generally write down in this Fourier transform x of n. X of n is the signal in x of n is the signal in time domain. ठीक है, x of n time domain में signal है. We write down x of n, it is equal to 1 by 2 pi 1 by 2 pi, then integral over 1 period minus pi to pi integral from minus pi to pi x of e raised power j omega n d omega. So this is one equation. Okay, we call it equation 1, where in this equation x of j omega, that is this portion or this part, x of j omega, what is x of j omega equal to? X of e raised power j omega, x of e raised power j omega, it is equal to summation of n equal to minus infinity to plus infinity, then x of n e raised power minus j omega n. Okay? These two equations are very important. First equation is the Fourier transform equation. The second equation is known as inverse Fourier transform equation. That is, the first equation is represents the signal in time domain analysis. The second equation, that is equation 2, it is x but in terms of j omega, in terms of complex sinusoids, So the signal here is represented in terms of Fourier in frequency domain. Okay, so first is in time domain equation, the second equation is frequency domain equation. So first is known as Fourier transform equation, the second is known as inverse Fourier transform equation. Inverse Fourier transform equation. Sorry, the first one is inverse Fourier transform equation. First one, because second one is in frequency domain. जो दूसरी equation है, it gives you the signal, it defines the signal in terms of frequency components, complex sinusoids. Therefore, the equation second would be Fourier transform equation. But equation first is inverse Fourier transform equation. That means if you take inverse of equation 2, you will obtain, or if you take inverse of a signal which is defined in a frequency domain, you will obtain a signal in time domain. That is what it means. Okay. So x of e raised power j omega, it is a signal which is the discrete time Fourier transform of the signal x of n. Okay. So this equation, it is basically discrete time Fourier transform of the signal x of n. Okay, x of n. And we generally say that x of e raised power j omega, that is a signal which is defined in frequency domain, and x of n, that is a signal which is defined in time domain. These are two now different terms. They are discrete time Fourier transform pair. Okay, these two are they are called as discrete time Fourier transform pair. What does that mean? That means, and we write it down like this, that x of n, it is discrete time Fourier transform is x of e raised power j omega. ठीक है, x of n का जो discrete time Fourier transform representation है, वो है x of e raised power j omega. But they are pair, discrete time Fourier transform pair. That means if you take inverse of x of e raised power j omega, you will obtain x of n. अगर आप x of n को dtft बनाओगे, then you will obtain x of e raised power j omega. Okay, so I'll write down here the transfer x e raised power j omega. It describes the signal x of n as a function of a sinusoid frequency omega. Okay, and is termed as frequency domain representation of x of n. So the transform, okay, जो हम यहाँ से x of n को transform कर रहे हैं, the transform or the transfer of x of n to x of e raised power j omega. What does that mean? It means that signal x of n is a function of complex sinusoid or a sinusoid frequency omega. ठीक है, इसका मतलब है जो आपकी x of n है, it is also a function of omega. That means it is dependent on omega. तो मैं उसकी आपको जब एग्जांपल हम करेंगे, हम इसको प्लॉट करेंगे, आई विल एक्सप्लेन दिस टर्म इन अ बेटर वे कि व्हाट डज दैट मीन. And it is generally known as frequency domain representation of x of n. It is generally known as frequency domain representation of x of n. And what is equation 1? Equation 1, I said it is usually termed as inverse. Equation 1 is termed as inverse discrete time Fourier transform equation. Okay. Why it is termed as inverse discrete time Fourier transform equation? Because since it maps frequency domain back to time domain, back into time domain. That means if you will take inverse of Fourier transform, you will obtain x of n mathematically. And since it transforms a discrete time Fourier transform equation back to time domain, that is why it is known as inverse of discrete time Fourier transform. Okay. So this discrete time Fourier transform, it is used primarily to analyze the action of discrete time systems on discrete time signals. Okay, what is the action of a discrete time system on a discrete time signal? When you apply a discrete time signal to a discrete time system, what is the action that is performed by the system on this signal? If you want to analyze that, so DTFT is the tool that will tell you what is the action of the system on this signal. Okay. Now, if you analyze equation 2, you have the infinite sum. Okay, the infinite sum in equation 2, it actually converges. I'll write it down here and I'll tell what does converge mean. See, this is an equation. Uh, say, for example, I have an equation e raised to power x. Okay, if x will tend to be infinity, if x will tend to infinity. If I plot then e raised to power x, it will go like this. So this is x here. As x tends to infinity, e raised to power x also tends to infinity. E raised to power x also tends to infinity. So we can say that the value of e raised to power x, it does not converge. Okay, it does not converge. See, this is a diverging curve. This is a diverging curve. They do not meet. This is not, they are not converging, they are not, uh, coming to a common point or a fixed value. So this is a diverging curve. This is converging curve. If you will, you know, exceed this curve, if you will elongate it somewhere, they might converge to a common point. So this might be the common point. But as far as this is concerned, these two curves, the first two curves, they are diverging curves. They do not come to a common point. They do not come to a common value. Okay. Similarly, e raised to power x is not a converging curve. It is a diverging curve. It goes on. If particularly or especially when x is infinity, then e raised power x will also tend to infinity for x tending to infinity. Okay? So if you have now another one, e raised power minus x, e raised power minus x, and if I say e raised power minus x, if x tends to infinity, then it will tend to 0. It will tend to 0. So e raised power plus x ऊपर से जा रहा था, e raised power minus x is like this. So this is x and this is e raised power minus x. अगर हम x का वैल्यू इंक्रीज करेंगे, then this curve will come down somewhere, it will touch down to 0. Okay, कहीं ना कहीं ये 0 हो जाएगी at x is equal to a very large value. When x will be equal to infinity, it will e raised power minus x will be 0. So this is a converging curve. ये किसी खास point पे आ रही है. It is a definite signal. आप इसको you can define its value at some point of time. Okay, when x goes to infinity, you can say what is the finite value. But if x goes to infinity in x e raised power x, then the value may not be finite. So this is converging curve. Okay, this is diverging. For example, this is an example of diverging, and this is an example of converging curve on a converging value. In the same way, I am saying that you have equation 1 here. Okay, we say that the infinite sum in equation 1. So we have equation 1. Okay, sorry, in equation 2, infinite sum in equation 2. We have equation 2 now. You can see that x of e raised power j omega, it is equal to summation from n equal to minus infinity to plus infinity. It is a summation, infinite summation. So the infinite summation of in x in equation 2, it converges. You know the meaning of converges now. It converges if x of n. What is x of n? X of n is the signal. Okay, that is somewhere here in the equation 2. X of n is the signal which is in time domain. If x of n is of infinite duration, तो अगर x of n infinite duration की है, तब हम कहते हैं that equation 2 converges if x of n has, sorry, finite duration. Finite, not infinite. It has finite duration. If it has finite duration, then we say that x of n, the value of x of n will converge. Okay, और जब converge होगा, then we mean that its value will be finite. Like I said here, two curves are converging here. At certain point, their value will be finite. Okay, this curve is converging. At some point, x is equal to infinity, its value will be finite. It will be equal to 0. It will be equal to 0. So the infinite sum in equation 2 converges if x of n is of finite duration and is finite valued. तो इसका value भी उस वक्त finite होगा, finite valued. Okay, but if x of n is of infinite duration, if x of n is of infinite duration, then the sum converges only for certain values or certain classes of signals. ठीक है, तो अगर सिग्नल है फाइनाइट ड्यूरेशन की, तब हमें पता है that its value or equation 2 will converge and it will have a finite value. But if the signal is of infinite duration, okay, infinite duration, then the sum, infinite sum that is in equation 2, it will not converge. It will not converge always, but it converge only in certain classes of signals. यानी कुछ कुछ signals में ही ये converge हो जाता है. And that too if summation of, this is a condition for this, if summation of x of n is less than infinity. जो x of n है, if you sum it from n equal to minus infinity to plus infinity, it is less than infinity. Okay, what does that mean? That is if x of n is absolutely summable. It is summable. Okay. Then the equation 2 will converge uniformly. Then equation 2 will converge uniformly to a function of omega, to a function of omega. I can write it down here. Then equation 2 will converge uniformly to continuous function of omega. Okay, omega. Now see, the other case would be if x of n is not absolutely summable. ये condition तो ऊपर है तब that it will converge if the x of n is absolutely summable. The second condition would be if x of n is not absolutely summable. Okay, if x of n is not absolutely summable but does satisfy this equation n equal to minus infinity to plus infinity, x of n whole square is less than infinity. It is less than infinity. Okay, that is x has finite energy. Then it can be shown that the sum in equation 2 it converges in mean square error sense. It can converge then in mean square error sense. ठीक है, अब ये सारी definitions हैं, many physical signals that are encountered in our engineering practice, they satisfy these conditions. ये जो conditions मैंने लिखी हैं. However, several common non-periodic signals such as unit step function, they do not satisfy these conditions. हर कोई जो non-periodic signal है बहुत सारी करती हैं ये जो conditions मैंने define की इनको करती हैं satisfy, लेकिन बहुत सारी ऐसे नहीं करती हैं. ठीक है, मैं इसका एक example करते हैं that will help us in giving a better picture of what we have discussed. If we will try to find the Fourier transform, I'll write an example here. This is an example. Okay. So I want to I want to determine the discrete time Fourier transform. So the question is find the discrete time Fourier transform of the sequence x of n equal to alpha raised to power n u of n. Okay, alpha raised to power n u of n. Just a second. Alpha raised to power n u of n. Okay. If we will solve it, how will we find the discrete time Fourier transform? We know the equation. We have discrete time Fourier transform equation 2. What is equation 2? Equation 2 is x of e raised to power j omega is equal to summation of n equal to minus infinity to plus infinity x of n e raised to power minus j omega n. That is equation 2. Okay? That is equation 2. Now, in our context, for our signal, we know what is x of n. We can substitute the value of x of n yet. X of e raised to power j omega will be equal to summation n equal to minus infinity to plus infinity. Then you have alpha raised to power n u of n. Okay. Then you have e raised to power minus j omega n. E raised to power minus j omega n. So this is in our context, the equation would be like that. What I have used here, I have substituted the value of x of n in the equation. We can further write it down as, this can be written as, since u of n, we know what is the value of u of n. U of n is actually unit step function. Okay, it is a unit step function in discrete time domain, u of n. U of t is the unit step function in continuous time domain. So u of n or u of t, they are always equal to 1. If it is not given, what is the amplitude? Then you will take it 1 because it is actually the signal of unit step function. If you remember from your classes, it is a of u of n. yeah, a of u of t. So if it is 2 of u of t, then you mean that the amplitude of that unit step function is 2. But if it is not given, then by default you will take it 1. U of n ho, because it is 1 into u of t. It is 1 into u of n. तो by default आप हमेशा 1 ही लेते हैं. So u of n is 1 now. U of n is 1. So my equation will become n equal to minus infinity to plus infinity, alpha raised to power n e raised to power minus j omega n. Okay, minus j omega n. Now you know that this equation you have alpha raised to power n. Okay, alpha raised to power n. If I take alpha from 0, 1, 2 up to infinity, you know that the value of alpha raised to power n, the value of Fourier transform
सर
equation
आपकी
is
वॉइस कट
सर आवाज ब्रेक हो रही है।
हो रही है. Abrar, what about Abrar? Abrar is here. रियानुल कादिर, रियानुल कादिर है यहाँ पे.
यस सर।
सर हो रही है वो ब्रेक।
पूरी आवाज हो रही है ब्रेक.
जी सर।
यस सर।
सर बीच बीच में हो रही है.
बीच बीच में हो रही है. Now it
यस
is
सर।
okay.
यस सर.
It is okay. सर अब
अब आ
ठीक
रही
है.
है.
अब ठीक है. ये म्यूट कैसे हुआ? Somebody muted me. ठीक है. So what I was saying that I have this equation now. ये फाइनल इक्वेशन मुझे ऊपर से रेड्यूस करते हुए मिली. ठीक है. तो ये डिस्क्रीट टाइम फोरियर ट्रांसफॉर्म इक्वेशन है. इट इज discrete time Fourier transform equation. What I am trying to say, if n is equal to 0, 1, 2, and it will approach to infinity, alpha raised to power n will approach to infinity. Because see, if and that is true when alpha is greater than 1. Okay, that is true if alpha is greater than 1. Say for example, alpha is 2. 2 raised to power 1 is 2. 2 raised to power 2 is 4. 2 raised to power 3 is 8. Then it will go on. 2 raised to power infinity will be infinity. तो अगर अल्फा का वैल्यू 1 से ज्यादा है, एंड अल्फा का वैल्यू 1 से ज्यादा है, then if n will go on to infinity, the value will not converge. Alpha raised to power n will not converge. It will diverge. It will become unstable. If alpha raised to power n will not converge, तो DTFT, discrete time Fourier transform equation जो है, वो भी converge नहीं होगी. That will not converge. That is not going to converge. ठीक है? So I will write down this observation here. The sum that we have above, okay, discrete time Fourier transform is a sum. Okay, it is a sum equation. I'll write this sum diverges for alpha greater or equal to 1. Okay, alpha greater or equal to 1. Okay, so it will diverge. It will not be stable if it is, I will say, greater or equal to 1. But for alpha which is less than 1, अगर हम alpha का value करेंगे, assume that it is less than 1, then we have a convergent geometric series. Okay, then we have a convergent geometric series. That means our sum will converge then. Our sum will converge then. Now see, if this is equation, say for example, this is equation 3 here. Equation 3 can be written as x of e raised to power j omega. It will be equal to summation of, okay, summation of see u of n, यहाँ पे u of n था. So I think I should write down here from 0. I should write down n equal to 0 to infinity. 0 to infinity. Why? Because u of n, you know that u of n is always defined from 0 to infinity. 0 से माइनस में जब हम जाएंगे यूनिट स्टेप फंक्शन 0 होती है. तो ये फंक्शन तो जीरो होगी, तो यहाँ लिमिट्स चेंज होंगे जब हम u ऑफ n को अप्लाई करेंगे इस पे. So we have actually n equal to 0, then to infinity. Equation 3 will become this thing. Okay. And you can take, you have alpha raised power n, then you have e raised power j omega n. दोनों में n है power. तो उस n को आप कॉमन निकाल सकते हैं. You can write down alpha e raised power j minus omega. ठीक है. फिर आप लिख सकते हैं whole raised power n. So this is one and the same thing. ये एक ही बात है. This is now a geometric series. This is now a geometric series. So it is summation n equal to 0 to infinity a raised power n. Okay, a raised power n. And you know that this can be simplified. Say, for example, now this could be written as equation 4. We can write down that by geometric series equation, a simplification, we can write it down 1 divided by 1 minus a. Okay, so it is 1 minus alpha e raised power minus j omega. Okay, j omega. So this is true when alpha, the value of alpha is less than 1, then only it will converge, otherwise the equation will diverge. Okay. And this, there is another condition that, see, if alpha is real valued, if alpha is real valued, then we may expand. So this is j here, this is j. Okay, we may expand the denominator of equation 4, the denominator of equation 4, simplified equation, using Euler's formula. Euler's formula to obtain this. Okay, to obtain this. What is the Euler's formula? I will just apply it here. So my discrete time Fourier transform x of e raised power j omega will now become 1 divided by, so you have e raised power theta. Okay, e raised power theta. We have e raised power theta. अच्छा, हाँ, बिल्कुल. We have e raised power theta. We can write it like this. It will be 1 minus alpha times cos of theta. E raised power j theta is equal to cos of theta plus sin j sin theta plus j sin theta. ठीक है. So this will be further equal to 1 divided by 1 minus alpha cos of omega plus j alpha sin of omega. रोल नंबर 24, ये ठीक कर रहा हूं मैं.
Yes, sir.
Okay, what about Rizwan is here? Rizwan, ठीक है ये?
Yes, sir.
Okay. Now see, this is my equation now. अब हम इसका magnitude भी निकाल सकते हैं. We can find its phase also. Okay, this is my equation. इस equation से हम magnitude भी निकाल सकते हैं. We can find magnitude spectra and we can find phase spectra also. Okay. तो magnitude spectra and phase spectra can be calculated. Spectra of x of e raised power j omega. We can find that. So how can we find out the magnitude spectra? Magnitude means magnitude of x of e raised power j omega. E raised power j omega. So magnitude. This will give me the magnitude spectra. Okay. Now see, we have a number that is like this. It is you have a real number and you have a complex number, imaginary number and real. Okay. See, you have, this is x plus j y, या a plus j b. This is in this form. तो अगर इसका magnitude निकालना होगा, how will we find magnitude? it is
Sir,
a square
सर ये माइनस में तो आएगा सर, माइनस अल्फा टाइम्स कॉस थीटा प्लस,
minus
minus j alpha
वो माइनस
sin
आएगा ना, माइनस जे अल्फा।
j alpha.
जी सर
I think it should be here minus. It is cos theta minus j sin theta. ये यहाँ पे
yes
पहले ये असल में यहाँ ऐसे था. That is why it is plus. ठीक है, ये असल में ऐसे था ये माइनस cos theta minus j sin theta. It is equal to e raised power. असल में है e raised power j theta is equal to cos theta plus j sin theta, लेकिन e raised power minus j theta is equal to cos theta minus j sin theta. ठीक है, ये असल में e raised power ऊपर minus j theta है. So the equation is like this. So that is why I have written a positive sign there. Now see, you have, this is a and this is b. So the number is like this, x plus a plus j beta. If you have to find the magnitude, then you go for like this, a square plus b square under root will be magnitude. ठीक है, अगर इसका एंगल निकालना होगा, then it will be minus argument of minus tan inverse b by a. So I will first find the magnitude. Magnitude will be, it will be 1 divided by, then you have 1 minus alpha cos of omega, this is a whole square. Okay, this is a whole square. Okay, then I have another, which one? Then you have alpha sine of omega whole square. Then you have square root on the top. इसका magnitude अगर निकालेंगे, this is how we can find it. So then this equation can be written as 1 divided by, it will be 1 square means 1, ठीक है, फिर it will be plus alpha square cos square omega, then you have minus a square plus b square minus 2ab minus 2 alpha cos of omega. तो ये तो हुआ पहली टर्म का. ठीक है, then I will have second term, alpha square sine square omega. Then you have at the top square root. This will now become, see, it can be written as 1 plus, then you have alpha square cos, I'll write down like this, cos square or cos square omega plus sine square omega minus twice alpha cos of omega. I have taken alpha square common from two terms. So what it will become now, it will become like this. You have 1, okay, plus then you have alpha square, because cos square theta plus sine square theta will turn to 1. Then you have minus twice alpha cos of omega. ठीक है, yes, I think that is correct. ठीक है. And if we try to find out this is my magnitude spectra. Okay, ये magnitude spectra है. So magnitude of x of e raised to power j omega will be equal to this thing. अगर हम इसको प्लॉट करेंगे, it will give me the magnitude spectra. ठीक है, अगर इसको प्लॉट करेंगे. The second thing is phase spectra. Phase spectra. Phase spectra कैसे मिलेगा मुझे? Phase spectra. How will I obtain phase spectra? Phase spectra can be calculated by argument of वो तो magnitude था, magnitude of x of e raised power j omega. So argument of x of e raised power j omega will give me the phase. Okay, what is it equal to? Minus arctan माइनस असल में था प्लस arctan. ठीक है, ये tan इनवर्स था, लेकिन क्योंकि ये डिनोमिनेटर में है, अब इट विल बी माइनस arctan. ऊपर मैंने ये पीछे एक लेक्चर में आपको बताया था, व्हेन यू हैव 1 एट द टॉप, मैंने कहा था शायद tan 0 एंड tan pi इट विल बी इक्वल टू -1, फिर इट विल बी 180 माइनस समथिंग 180, इट विल बी pi माइनस दैट एंगल, सो दैट इज इक्वल टू माइनस टाइम्स दिस, क्योंकि डिनोमिनेटर में है आपकी टर्म, इसीलिए माइनस टाइम्स आएगा. तो इट विल बी tan इनवर्स ऑफ b बाई a. व्हाट इज b? b इज माय दिस थिंग. ओके, दिस इज b, या यहाँ पे ऊपर देखते हैं. सो इस इक्वेशन से देखेंगे व्हाट इज b. So my b is alpha sine of omega tan inverse of b by a. What is a? 1 minus alpha cos of omega. Okay. Now see the magnitude and phase spectra are given by these two equations. ये दोनों equations जो है, एक equation देगी magnitude spectra, दूसरी देगी, the second one will give you the phase spectra. If we plot these magnitude and phase spectra, अगर हम इनको करेंगे, let us first try to plot magnitude spectra. Okay. For now see in magnitude spectra you have two variables. एक तो है आपके पास alpha, ठीक है, alpha भी एक variable है, you don't know. Then you have frequency. And you know magnitude spectra is always plotted against frequency. ठीक है, it is magnitude something versus frequency. magnitude spectra जो है वो या phase spectra ये सारे frequency domain के हिस्से हैं. They are in frequency defined in frequency domain analysis. So that is why they are plotted against frequency. Now you have another variable alpha. So let us first fix alpha. हम कहेंगे for a value of alpha equal to 0.5. अगर हम assume करेंगे that value of alpha is 0.5, ठीक है, तब जो हमारा ग्राफ दिखेगा it will be something like this. So let us say this is omega is frequency, this is omega frequency. Say for example this is omega equal to 0. Okay, this is omega equal to pi, this is omega equal to 2 pi. Then this is omega equal to minus pi, then this is omega equal to minus 2 pi. तो मैंने जीरो को शिफ्ट किया. नॉर्मली जीरो होता है यहाँ पे, ठीक है, लेकिन मैंने जीरो को वहां नहीं रखा. आई हैव शिफ्टेड इट. देयर इज नो प्रॉब्लम इन दैट. या अगर आप इससे इफ देयर इज सम प्रॉब्लम इन दैट देन आई कैन ड्रॉ दिस एक्सिस समवेयर हियर. तो ये एक्सिस मैं यहाँ पे भी ड्रॉ कर सकता हूँ, इसमें कोई परेशानी नहीं है. देयर इज नो प्रॉब्लम इन दैट. ओके, so whether I draw the axis there or here, it doesn't matter. Now see in this equation, if alpha will be equal to 0.5, so I will have 1 divided by root of 1 plus 0.5 square. 0.5 square means 0.25. So it will be 1.25. 1 plus 0.25 means 1.25 minus 2 into 0.5 will be equal to 1. ठीक है, 2 divided by 2 it is 1. फिर होगा cos of omega. अब मेरी इक्वेशन ये बनेगी. अब इसको मुझे प्लॉट करना है. Now see at omega equal to 0, at omega equal to 0, cos of theta is equal to 0, cos theta, cos of 0 is equal to 1. ठीक है, cos of 0 is equal to 1. 1.25 divide 1.25 minus 1 will be 0.25. Then it will be square root of 0.25. तो डिनोमिनेटर में 0.25 है, so it is numerator divided by 0.25 square root. ठीक है, ये तो एक केस है. Let us talk about cos. यहाँ क्या है, यहाँ है for omega is equal to 0. For omega is equal to pi, for omega is equal to pi, cos of 90 is 0. ठीक है, cos of 90 is 0. Cos of 90 is 0. Cos of pi is equal to minus 1. Cos of pi it is equal to minus 1. तो उस वक्त जब होगा this is omega equal to 0. दूसरी टर्म होगी for pi, for omega equal to pi, it will be equal to 1.25 minus, अब cos of pi will be equal to minus 1, तो ये होगा ऐसे. तो ये बनेगा 1.25 plus 1, तो it will be 1 divided by 2.25. ठीक है, तो ऊपर होगा न्यूमरेटर जो 1 है, नीचे होगा रूट ऑफ 2.25, लेकिन यहाँ आपका जो है थीटा है पाई. ठीक है, अब देखिए न्यूमरेटर डिवाइडेड बाय स्मॉलर नंबर इट विल बी ऑलवेज अ बिगर नंबर. न्यूमरेटर divided by smaller number it will be a bigger number. So this is a bigger number. Numerator divided by larger number it will be a smaller number. ठीक है, ये एक छोटा नंबर बनेगा, it is a smaller number. तो this is a bigger number. So that is why at zero जितना भी इसका होगा वैल्यू, जो भी होगा, I will write it down like this. यहाँ 0 है और यहाँ फॉर एग्जाम्पल हम 2 रखते हैं, फिर यहाँ 4 है नॉट हियर, हियर यू हैव 4। ओके, इसका जो ग्राफ आपका बनेगा वो कुछ इस तरीके से बनेगा। चाहे आप थीटा को पाई से लें, जीरो और 2 पाई इज वन एंड द सेम थिंग। ओके, 0 एंड 2 पाई इज वन एंड द सेम थिंग। ये थीटा है, दिस इज ओमेगा, दैट इज एंगल। जितना ये चेंज होगा तो आपका जो ग्राफ बनेगा, इसको प्लॉट, वो ऐसा होगा। अब इसमें जो पीक होगा वो होगा 0 पे और 2 पाई पे, बिकॉज 0 एंड 2 पाई इज वन एंड द सेम थिंग। 0 एंड n पाई, व्हेन n इज एन इवन नंबर, इट इज ऑल्सो सेम थिंग। ठीक है, 0 2 पाई तो एक ही है। तो 0 पे इसमें ज्यादा बड़ा होगा, बिगर वैल्यू होगा, बिकॉज यू हैव अ बिगर नंबर। बट एट पाई यू हैव अ स्मॉलर नंबर, तो आपको वहां पे वैल्यू उसका कम हो। x of e raised power j ओमेगा। ठीक है, ये है मैग्नीट्यूड स्पेक्ट्रम, मैग्नीट्यूड स्पेक्ट्रा, दिस इज मैग्नीट्यूड स्पेक्ट्रम एक्चुअली। Similarly, the phase spectrum is also plotted in this fashion. Phase spectrum भी ऐसे ही होगा, इसका कुछ ऐसा होगा, something like this. Okay, मैं कोशिश करूंगा, I will plot this equation in the MATLAB. If I am successful in plotting it in the MATLAB, I'll definitely show you how it will go. अगर आप अल्फा का वैल्यू चेंज करेंगे, if you will change the alpha value to 0.9 from 0.5 to 0.9, then the magnitude spectrum will not be resembling like this. इसकी शेप भी चेंज होगी। Even the phase spectra will also change। ठीक है, phase spectra भी चेंज होगा। I'll stop here. If you have any question, आप पूछ सकते हैं। किसी बच्चे को कोई सवाल तो नहीं है? रिजवान को कोई क्वेश्चन तो नहीं है?
नो सर।
व्हाट अबाउट बीनिश? बीनिश को कोई सवाल तो नहीं है?
नहीं सर।
ठीक है, I'll stop now. We'll solve a few more questions in our next lecture.